Have you ever thought about mathematics? You may be trained as a mathematician like me, but you were not good at physics. You were not good at physics like me. Let's take something. Take and take a square. Let's add motion to it. It's very abstract. I watched some videos one time on French engineering. This is just AI engineering. Take a square. Let's add motion to it. Okay, I'm just talking about just in chat. Just in chat, man. It's gonna hit me with a subscription. Well, you know what? It's still gonna do it. Just in chat, man. Take a square. Let's add motion to it. To visualize a square in motion directly here in YouTube, I'm not talking about. I'm talking about in terms of him. I'm talking about in terms of physics. So that may not have been the right thing to say. Let's add kinematics to it. Let's add kinematics to it. So motion was not the right word. We have a square. We're going to add kinematics to it. When we introduce kinematics to a square, we transition from a simple geometric rotation to describing its motion in space using vectors and scalar quantities. So if you're starting from zero, like me, or starting from scratch, you're going to have to know vectors. You're going to have to know all this kind of stuff. There's going to be translational kinematics through position, velocity, and acceleration. Rotational kinematics through the square rotates around its center. We define its motion through angular variables. Integrated motion, rolling square. So how do we get a complete picture of physics for the square? Like, we need to add dynamics, statics, gravity, possibly aerodynamics, possibly fluid dynamics if it's in the water. So this, once you get a hold of these objects where you add physics to it, like going back real quick, you added not motion. That was the wrong word. You added kinematics to it. You got some equations. You got kinematics to it. Oh crap! What happened? Added kinematics to it. You want to get a complete picture of physics. You're asking. You're gonna have to add dynamics, statics, and gravity. Okay. If you want to get into engineering aircraft, you're going to have to go with aerodynamics. If you like boats, you're going to have to do fluid dynamics. If you're going with electricity, you're going to have to do electromagnetism and circuits. To get a complete picture of the square, we must move beyond pure kinematics, which only describes how it moves, and enters the realm of Newtonian mechanics, which is dynamics, when we analyze why it moves. So you're going to have to get equations of motion from that, like for F equals ma, from linear dynamics, rotational dynamics. Statics is when it's in equilibrium conditions, like it's not really moving around. It's resting on a surface or held in place. Okay? There's going to be gravity and potential energy. And when you introduce a fluid like air or water, also, if you're going in EE direction, add electromagnetism, and I will say and thermo, need environmental analysis. What's happening when it's just sitting around in the environment? If you add electromagnetism and thermodynamics, shifts the square from a mechanical object to an active system, such as it might be a sensor, a micro actuator, or an electronic component, the little square thingy. So it's what you want to do. It's what you want to do. You have EM, power input, thermo, fluids, dynamics. Like example application, imagine the square is a MEMS micro electromechanical system, gyroscope. If we were mech engineering, what else do we need to know? As far as this physics and stuff, we step in the shoes of a mechanical engineer. We stop looking at the square merely as a theoretical object or electronic component, start looking at it as a manufactural load-bearing system. So you're going to need solid mechanics and material science, straight, so you can do stress analysis and fatigue analysis, rain flow counting algorithms, vibrations and modal analysis, tribology, wear and friction, manufacturing design for manufacturing. So, what if we want to engineer something like a boat or plane? So you're going from abstract kind of physics to abstract engineering or fundamental engineering to like actually engineering something. We're moving from a theoretical square to an engineered boat or plane, marine and aerospace. The physics shift from studying an object to studying a vehicle system. The square now becomes a hull or a wing fuselage section, and the environment becomes the primary constraint on your geometry. Aerospace perspective. It's a plane, you gotta have to study lift and drag, aeroelasticity, weight versus strength, marine perspective as a boat, buoyancy and stability of a square or a box-shaped hull. Even architecture, you might have like a square building with a door, just a regular ass door or an arch inside of a square building, and where are you going to build it? Square building, you have shear wall problem, door discontinuity, foundations, environmental engineering, the thermal, where are you going to build the thing, human factors. I was thinking about a 4-story square monument building other architectural elements can we add, like gargoyles, pylons, things like that? What are those things called in front of the porch? Have a 4-story monument transforms the project from a basic structure into a composition of architectural language. Hopefully you're gravitating towards something like bicycles, vehicles, something that you might have to force yourself on a track and into a groove. Oh, another thing is locomotion. In case you want to study trains, but that's gonna be you sitting at the house playing with little toy trains and shit. Composition of architectural language. We have managing visual weight, history, and civic presence. It might not turn out to be square, it might be a rectangle. I was thinking about pylons, or monumental gateway structures, or massive vertical piers. In a square monument, placing them at the corners or flanking the entrance elevates the building's perceived stability. Gargoyles for managing hydrology. Gargoyles are often misunderstood as mere decoration. They're actually functional civil engineering tools. Problem on a flat roof or a square monument. Rainwater pooling at the edge is the primary cause of structural decay. It leads to erosion, stain, moisture infiltration into the facade. The engineering solution, is that facade or facade? Is that facade or facade? I don't know. The gargoyle is a sculptural downspout. It projects the water away from the face of the building, preventing the corrosive streaking. Yeah. You can design biomimetic gargoyles. Yeah, like we want to design a slight upside down parabola for roof, so it drains rainwater off. Designing a roof with an inverted parabolic curve, a saddle or vaulted shape is an excellent engineering decision. It's visually striking, structurally it's highly efficient at handling gravity loads. I have a parabolic arch as a roof. And then I guess you would spend a concave ceiling acts like a whispering gallery. You can focus sound waves from the floor up to a single focal point, which might create dead zones. That's something I didn't think about. Something I did not think about, that acoustic analysis, and then wanting to get out those, what are those things called? Something where you take out 2 frequencies. You have to delete the 2 frequencies. I can't remember. Resonant EQ. You know what? Resonant EQ, where you take out 2 frequencies. This is going to completely a resonant EQ or notch filter, peaking EQ, sweep and destroy. So you have audio engineering, stuff like that. Q factor, to find a Q exists, see over bandwidth. Like, let's do let's see if we can get this building. Can you render the current 4-story monument square building with gargoyles and slight domed roof? What would a domed roof look like on a big square building? Slight domed roof. Let's see if Gemini understands this. It's kind of, sort of. It's not that bad. It's not that bad. I kind of like that. I'm gonna be honest. It looks like a really, really nice library. It's like a really super nice library. I mean, it's kind of nice. It's pretty damn nice. I went with, like I said, I went with pylons. I thought I was going to use 4 pylons. Can we change it? Change it so the door is on the side wall, just a square building, arched roof. Change it so the door's on the side wall. Just a square freaking building. But I'm gonna tell you something. Whatever this is freaking nice. Redone Civic Monument. Dang, redone. Dang. Still going with 4 stories. Kinematics and dynamics. We defined how the building sits in space and resists forces. Environmental fluids, structural, aesthetics. Look at this. That's kind of crazy. That is kind of sort of crazy. But change that roof. Change that roof to like a massive triangular roof. But whatever this is, I don't think this makes as much sense unless you're putting a whole bunch of like AC type stuff in there. Like a thing looks like a monument slash industrial. Kind of a jig there. I do like the gargoyles though. Look at that. Functional gargoyles are draining off rainwater. Yeah. That almost looks like kind of cool. Kind of cool. There's only 3. It's like 3 or 4 stories. Oh, pretty nice. Use 2 corner doors. There's 2 corner doors. What happens? I don't think get understood. Okay. Let me go back. Take an octagonal. Just think it's a 7-story building. No, look at this. There isn't a single globally famous 7-story octagonal building that stands out as a unique landmark, though several structures, often historical pagodas or towers, featured a specific architectural profile. Now, there's, I just said there's not globally famous, but there's notable 7-story octagonal structures like Juji Tower. There's some towers. Let's design landmark. Add like a fake hillsides to it. So now we're talking about the landscaping, almost like some Disney World stuff. The manscaping, the landscaping, check that out. What a kind of fun stuff. Ended up wrapping it. Wrapping it a little bit. I like that. It's got kind of looks like a penis. Kind of maybe more vaginal. That is an aesthetic thing. You can, if you're using AI, you can make something more penile or more vaginal. Yeah, see. Might not be her thing, but anyway, have fun with that.